Okay, so yeah, it's right here. We're gonna cover 5.5 today, rational polynomial rational inequalities. We'll also talk about exam 2. I'm not quite sure how much time I'm gonna need for this. Do you all have a lot of questions on exam 2? Things you want me to go over at all? A few problems? Yeah. Okay, so I'll try and save about 20 minutes at the end for this. Maybe even more, we'll see. So if you have any questions about what you can bring to the exam, all that, we'll get to that, all right? 5.5, this material will not be on the exam. I believe it's on the review I gave you. It said at the very last problem, it says solving inequalities. I'm not gonna scratch that, right? So we're gonna just keep that for the next test. All right, here we go. All right, so we're going to be doing polynomial and rational inequalities. We just got finished and we're about to have a test on Thursday over sketching polynomial functions and rational functions, right? But now we're going to talk about inequalities involving those two types of functions. So we've already talked about quadratic inequalities earlier this semester, and I'm just going to run through very quickly how we did these. If you're given a quadratic inequality, so it's quadratic, you have to recognize that. You have an inequality symbol instead of an equal sign. The first thing you do is you turn it into an equation. Okay, you turn this into an equation, and then you go about solving that quadratic equation. In this case, I factored it, and then once I factored it, I set each factor equal to 0. And then the very important next step, which is to plot your two x-intercepts on a number line, and then that partitions our number line into 3 sections. And I put these little red X's here. What am I going to do with the red X's? Y'all know what I'm doing here?
Test points.
Test points. I'm going to pick a point right here. Let's pick a point to the left of -1. Let's say -2. Somewhere between -1 and 6, like 0. And something over here like 7. And I'm going to test those into the original inequality and see if it comes out to be true or false. Okay, that's all I'm going to do. So I now test, let's test -2. To do that, I plug in -2, I square it, -5 times -2, and then -6. And then I'm asking this question, is that bigger than 0? So let's see, we get 4 here when you square -2. 2 negatives become positive, so +10, -6. Is that greater than 0? 14 take away 6? Yes? That works, right? What that tells me is that everything over here works, right? Everything over here works. Then I test 0, right? When I test 0, plug it in. 0 squared minus 5 times 0 minus 6. Is that greater than 0? Checking. No, it's not, which means this doesn't work. And then if you test 7, it will work, okay? So our final answer is we're trying to figure out the values of x that make this true. It's everything to the left of -1 and everything to the right of 6, right? Left of -1, do I include -1 or not? No, why?
It doesn't include it.
How? Do you know that?
The sign?
Yeah, because here we don't have an equals, right? What's happening at -1? At -1, it's equal to 0, right? I don't want it to be equal to 0. I want it to be greater than 0. So I do not include -1, and I do not include 6, right? So the final answer is everything to the left of -1. So I write that -infinity, comma, -1, don't include -1, union, and then 6 to infinity. So we're using intervals. Our answer is a set of intervals, right? Okay, this is all stuff we've done before, right? Does it look familiar? Yeah, a little bit? Okay, today what we're going to do is we're going to now extend this out, and we're no longer going to be restricted to just quadratic. This can be a polynomial or a rational expression, all right? And your homework assignment is up on the board here. You're supposed to do numbers 19 through 41 odd. I'm going to do some of the evens because the method for these is pretty much the same for all of them. You just need to see like a set of examples. We're going to follow something very similar to this. Okay, so let's start with polynomial inequalities first. And I'll give you some examples, and as we're going through the examples, I'll kind of stress to you the things that are important here. Polynomial inequalities. All right, let's do number, you know what? Let me make up my own first. Yeah, you know what? No, we'll do that. We'll do number 20. So let's say we've got x minus 5 in parentheses, and then the next one's x plus 2, and then that's squared, and we want to know when that's greater than 0. Okay. 2 days from today, right, on Thursday, you might walk into the test, and you might be given a polynomial function where you have to do synthetic division and do all that stuff, right? And then get it down to this. And then that tells you, okay, you have x-intercepts at 5 and -2, and you cross and you bounce, yes? Right? That's something you're going to have to do on Thursday. What we're doing is we're saying, basically in this problem, we're saying, where is this function greater than 0? So where's the graph of that function above the x-axis? Does that make sense to you? So remember, our graph's going to be like, you know, might bounce and stuff like that. We want to know where it's above the x-axis. So you could, if you wanted to, just go graph that function, right? You could. But I think the more efficient way, in a way that like when you're in calculus down the road, you're not going to go graph the function. You just need some way that's going to be kind of quicker without having to do a graph. So here's what we're going to do. We're going to turn it into an equal, all right? Just like we did with the quadratic. Turn it into an equation first. Okay, so first step, we set it equal to 0. And there you should be able to set each factor equal to 0, right? So set this equal to 0, what do you get? X is 5, right? And then this one, you set that equal to 0, you get x is -2. And then I'm going to draw a number line. And I'm going to put those points. And that's going to break up my number line into sections. And then pick test points. Exactly the same method, understand? As we did with the quadratic. So I'm going to go here. Let's go -2. Let's go 5. That. Let's test some points. Let's go over here. We got some like -3 maybe. 0's in here. 6. And I'm going to test those into the original inequality again and see if it works. Right? So we test -3. Now, when we plug that in, we get -3 take away 5, and then -3 plus 2 squared. And the question is that greater than 0 or not? Well, this is -8, right? And this is -1 squared. Well, this is always going to be a positive number, isn't it? No matter what, because I'm squaring it. But I'll just put here -1 squared. Is that greater than 0? Well, this is -8 times 1, because when you square that, you get positive. And is that true? No, that's not true, which means this section doesn't work, okay? Now I've got to test 0. So plug that in, we get 0, take away 5, and then we get 0 plus 2, and then we square it. Is that bigger than 0? That's the question. This is -5 out here. And here we get 2 squared. Is that greater than 0? No, right? It's -5 times 4. That's -20. -20 is not greater than 0, right? So that doesn't work, which means that doesn't work, right? And then we test what do we test? 5? Sorry, 6. So if you go 6, take away 5, and then you do 6, add 2, squared. Is that bigger than 0? 1, 8 squared, 64. Is that greater than 0?
Yes.
Yes. Okay, so finally we get something that works. So right now it looks like everything to the right of 5 works. Do we include 5 or not? We do not include 5 because we call this a strict inequality, greater than, right? Only greater, not greater than or equal to. So our answer will be from 5 on forever, so 5 not including 5 to infinity. There we go. Do y'all see it's the same method as quadratic inequalities? Now this one was given to us, it was already factored, right? We're going to get some problems where we actually have to get to this. We're not given this to start. Questions? Okay, I'm going to change the problem. And you'll see a green marker anywhere. Oh, can you, on the top of that thing, can you grab that? Toss it over here. Thank you. Okay, so I'm going to change the problem slightly, and let's see if it changes any of our work. Let's make this greater than or equal to. It's dead. All right, let me get one. There's one over here. Think about what's going to happen if I change that and I put an equal underneath it. How much of your work changes, right? Do you still set it equal to 0? You still do this step? Yes? So you'll still do this, okay? You'll still do this. You still do this. You still do this. Everything's the same, right? But at the end, right, can we include 5? Yes. Yes, we can. I'm going to put it here. So we can include 5 and everything over here, right? So that would change that to a bracket 5 to infinity. Am I done? No. What's missing? -2, right? Look, -2 makes this 0, doesn't it? And we're allowed to be 0 this time. Y'all see that? So I need to include just the number -2. How do I do that? It's not an interval. Do y'all see that? It's not an interval, just a single point. So what I'm going to do, I could do it before this or after. I'm going to do a union, okay? How do we represent a single number? We don't use the bracket and the parentheses. What we do is we do a brace. We put the number, -2, and a close brace like that. You'll see the difference between those two answers? Ask questions. In the first problem, it had to be greater than. Was there a question? Yeah.
I don't understand what you mean by including.
Okay, so if I change this to, hey, you let me know what values of x will make this greater than or equal to 0, right? The first thing we do is we set it equal to 0, and we said there are 2 numbers where it's equal to 0, right? There's 2 numbers where it's equal to 0, for sure. So I know these 2 numbers are part of my answers. But then when I broke up the number line, I said, okay, everything to the left of -2 didn't work. Everything between -2 and 5 didn't work. Everything to the right of 5 did work, right? So, okay, I take everything to the right of 5, but I need to include 5 this time. So there it is. But how do I represent just that number 2, right? To the left didn't work, to the right didn't work, but I need that number 2. So I put it right here. Is that good? Yeah. Everyone? So do you see just a slight change in this changes our answer pretty significantly, right? Goes from this to this. Okay, let's do another one. I want to. Because it's equal. Because it said equal. Yes, because it said equal. Okay, I want to do number 20. I want to do 23, but that's one of yours. I'll do number 22, but I'll change the problem a little bit. So what if we have? I'm going to change the problem. It's not going to be that one. What if we have x cubed is less than or equal to 8x squared? Okay, so look at this carefully, because this looks a little different than what we've been given before. right? In the two problems I gave you, right, that we've looked at, it was something, and then I put like greater than 0 or greater than or equal to 0, right? So I had a 0 on one side, didn't I? Here we don't have that. So when you're doing polynomial inequalities, the first thing you want to do is move everything to one side. Okay, get everything over to one side. Do not divide by x squared. Do not divide by x squared. Because if you divide by x squared, you're dividing by a variable, and what if that variable is 0? Right? Then you're dividing by 0, which can be a problem. So the standard procedure here, let's subtract 8x squared on both sides. Okay, y'all agree? That's just moving the 8x squared to the left side. And now I'm going to try and figure out if I can factor this because I need to set it equal to 0, right? So let's do that. Let's set it equal to 0. Okay, I'm doing blue because this is where we actually make that change. I want to set it equal to 0, right? And now we try and factor. Can you factor that? Yeah, just pull out x squared. Left with x minus 8 equals 0. Can you tell me what values of x make that 0? What would make this 0? 0. So x is 0. What would make that 0? 8. Okay, those are my two zeros of that, right? Or the two solutions, two x-intercepts if you want, right? If this was a function, those are the x-intercepts. So now I draw a number line. I put 0. I put 8. That breaks up my number line. I have 3 test points, right? 3 test points. Here, here, here. So let's go with -1, I don't know, 2 and 10. And then test, right? Test them. Where am I going to test them? Where do you test them? Always go back to the original. That way, you don't make any mistakes. I'm going to test them right there. I'm going to plug -1 in for x on both sides and see what happens, see if it's true or not. So I'm doing -1 cubed. Is that less than or equal, right? This is a question. Is that less than or equal to 8 times -1 squared? Well, what's -1 cubed? -1. Is that less than or equal to, let's see, this is -1 squared is 1, right? 8 times 1 is 8. So is 8 bigger than or equal to that? Yes, right? Yes. So that works. Now we have to test 2. If I plug in 2, I'm going to do 2 cubed. Is that less than or equal to 8 times 2 squared? Okay, what's 2 cubed? 8. Is that less than or equal to 4 times 2? It's 32. Is that true? That's true as well. That means everything here works. Now we test 10. And that's 10 cubed. Less than or equal to, is it? Less than or equal to 8 times 10 squared. Okay, what's 10 cubed? 1,000. Is that less than or equal to 10 squared is 100 times 8? It's 800. Is 1,000 less than or equal to 800? No, that doesn't work. Okay? Any questions so far? Ready for the final answer? It's everything here, right? Forever. It's everything in here. Do I include 0? Yes, because 0 is what made this equal 0, and we wanted it to be equal as well, right? So I do want to include 0. Do I include 8? Yes. Because again, 8's what makes it 0, and I want it to be equal, right? To 0. So I can do that answer as one interval. Do y'all see that? It's just everything to the left of 8. That's it. So I'm just going to write negative infinity to 8 with a bracket on the 8 to include the 8. See, I don't even have to worry about the 0. It's included. When I say from here over forever, it's included.
If we wrote it out with a union, would it still be right?
It'd still be right.
Out of habit? If you
Yep.
did it?
Yeah, it'd still be right. As long as you put a bracket on one of the zeros, on one side. Or you can do it on both as well. All right, good? Okay, I'm going to change the problem. Let's see how it changes our answer. What if I come in here and I take that away? So that's no longer here. You still do all this, right? You do all this. But how does it change your answer? Do we want to include 0? We don't. So it'd be don't include 0, but everything this way, right? Do we want to include 8? No, we don't. So it'd be everything like that. See, now I'm going to have to do intervals to get this answer. I'm going to say first, everything, I'll do it right here. I'll do negative infinity all the way till I get to 0 with the parenthesis. And then union, now the other side of 0, 0, don't include it, to 8, don't include it, right? See, this takes the 0 and takes the 8 out of our answer. That's the way we represent it. This all right? Questions? All right, let's do number 28. Let's do 28. And I'm going to make a slight adaptation to 28, okay? Just a slight change to it. I want it to say x to the 4th plus 2x cubed. And then let's go with greater than 3x squared. Okay, this is a polynomial inequality, right? Do y'all see why they call these polynomial inequalities? Like if you make that inequality into an equal, you have a polynomial equation, right? It looks like a polynomial function. All right, so figure out what values of x would make that true. So things like this, what we're doing right here, are going to pop up in just random places throughout the rest of your mathematical life, right? I think I've said to you over and over how much this class is about like loading up a toolbox full of tricks, and so that way when we get into these other classes, we get to something like this and we can handle it, right? There's a bigger, this is like a sub-problem within a bigger problem, right? All right, here we go. First thing, what? Move everything over. Okay, get a 0 on one side. That's the standard approach. So I'm going to subtract 3x squared. I'll have greater than 0. Now change it to an equal, right? And then work with that. So we have x to the 4th plus 2x cubed minus 3x squared is equal to 0. Let's solve that equation. What can I do?
Factor out an x squared.
X squared GCF. So we're factoring, right? First step of factoring anything is GCF. We pull that GCF out, pull the x squared from everything. That's what we get. And fortunately, what's in that parentheses is a quadratic, and it is factorable, yeah? I hope that you could factor that. Maybe you need to do some scratch work on the side, but I trust that you could all get to this, right? Hopefully, yes. Now, you could do synthetic division if you wanted. Or you could do that little x thing where you put like -3 and then what two numbers multiply to be -3 and add up to be 2. However you do it, totally up to you. But you need to be able to do it. All right, so what makes this 0? 0. This one, -3, and 1, right? Okay, now what? Number line, test points. Number line, test points. Number line, 0. -3. Ah, shit, 1. I said shit 1, why? Because I'm going to have a test point between these two. It's going to have to be a fraction. And I'm not happy about that. But it is what it is, right? It is what it is. All right, so over here, I picked something like -4. Here, -1 maybe. Okay, 1/2. And let's go with 2. We've got to plug those 4 test points, right? Now, let me show you something. Do you understand what to do from here? Do you understand what to do from here? You like plugging in test points, like what you're supposed to do, right?
Just plug them into the original equation.
Into the original and see if it's true or false, right?
Yeah.
Let me show you a slightly different approach that won't require any test points at all right? But what it does require is that you understand what you're about to be tested on Thursday. And that is, if you look at this as a function, right? A polynomial function. What is its degree? 4. What is the leading coefficient? 1. So that means it does what on the ends? It goes up on both ends. What are the x-intercepts? Right here, right? Do we bounce or cross here? Bounce here. What do we do here? Cross. What do we do here? Cross. So without doing any test points, here's what I know. At -3, if I were to graph this function, 0, here's 1. I know both sides go up, right? I know at -3 I do what? Cross through at -3. At 0 I bounce, and at here I cross. That's what that looks like as a function, right? Yeah? And what am I asking? When is this function what? Greater than 0. That means where is it above the x-axis? Where is it? There and there. And that's it. See, I don't need any test points. I don't need them. If I know how to graph it quickly, right? If I can graph it quickly, I can answer the question. Now, so if you test, if you do, I'm not going to show the work. If you tested this, you get yes, you get no, you get no, you get yes. That's what would happen. But you can see it from the graph that here I'm up, right? Here I'm up. So here I'm greater than 0. Here I'm greater than 0. Do I include -3?
Yes. No.
So the original inequality did not have a bar here, right? So I don't want -3. So it's going to be this to the left. And then I don't want 1, right? So don't include it to the right like that. That's where my graph is above the x-axis. And so my final answer here is -infinity to -3, parenthesis, union, and then 1 to infinity. So the reason why this section is right after the sections we just did is because we just spent all this time graphing, right? And you see how we can use the graph. This is not necessary. You do not have to do this, right? You could just test the points. But I think that might take more time, right? If you know what it looks like, you know how to sketch it, it should work out pretty clean. Okay, let me see what else we got here. Polynomial. I want to give you a harder one. Here's a problem. I'm teaching this is the STEM college algebra, right? This is the class for all of y'all have to go do more math, right? I'm also teaching the non-STEM version of this class immediately after this. And we do similar things. We just don't get into as much depth. Like we aren't going to do this, right? But they are having a test right now after today. And their last problem on their test is to sketch a polynomial function. So I'm going to give you all that one. Shit. So let's do this. I want us to solve this. It's x to the 5th minus 5x cubed. I would like to know when that's greater than x to the 4th minus 3x squared. All right, is that a polynomial inequality? Yes, that is a polynomial inequality. And we'd like to know when that is true. So first thing I'm going to do is bring everything over to one side, right? So I'm going to bring this over here. It'll become negative, right? I'm going to bring this over here. It's going to become positive. And I need to make sure I'm going to put everything in the correct order. So the highest power I'll have is x to the 5th. Then this x to the 4th comes over, becomes minus x to the 4th. This plus 3x, oh wait, no, next one is minus 5x cubed, sorry. And then this one comes over and becomes plus 3x squared greater than 0, right? Good? Now we're going to set that equal to 0, and then we're going to try and factor it. So we take this, set it equal to 0. And let me just double check that that is the problem. I don't want to go too much further. Wait a minute, hold on. I have a problem. Yes, I messed up, hold on. It should be x to the 5th minus, okay. Change the problem, make this a plus right here, okay? Make that a plus. This is a plus, and when you bring it over, it's now what? It's a minus, right? Yeah, and that means over here, it's a minus. Does everyone see that correction? Yeah? Okay. So now, factor. What's the first thing you can do? X squared, right? Greatest common factor. So x squared comes out. You're left with x to the 3rd minus x squared minus 5x minus 3 equals 0, right? That's pulling an x squared out of everything. Now this right here, that's 4 terms, right? We have to see if we can factor it. The grouping's not going to work. So this is where we can bring in what? Synthetic, right? Synthetic. So let's bring in our synthetic. And I'll have what here in my box? What are the numbers? 1, -1, -5, -3. And I have to make my list, right? My list is going to be based upon these numbers, right? But this is a 1, so I only have, what are the only things I'm going to try? 3, -3, 1, and -1, right? So I'm just going to start with 1. Does 1 work? Let's see. 1 comes down. 1 times 1 is 1. That's 0. 1 times 0 is 0. This isn't going to work. -5. Yeah, that didn't work.